I want to welcome all of you now to the next part of our forecasting series. And today we want to be examining some few things, apply, interpret, and compare time series forecasting methods. We're going to use manual calculation, Excel calculation, Python calculation on the same data set before we go to the real data set. We'll also be looking at the measures of accuracy. These are the 8 different forecasting techniques, classical ones available. We are not going to do all, we are going to do 1 to 6. Because the last 2 are quite deep, but we'll flag them along the way. So we shall look at naive forecast, which is also called random walk. In fact, it's even called the last period forecast. Then we'll look at the simple average, the moving average, weighted, and then simple, which is also called single exponential smoothing. Okay, so to do that, we are going to take this data set from Fast Chips. It's a leading producer of microprocessors. 6 months ago, it launched the sales of its latest microprocessor. And every month, sales in thousands are shown here for the initial 6 months. Sales are actually in millions of dollars. In the month 1 to 6, sales range from 17 to 28. So the first thing to do is to forecast for the next period, which is month 7, using the naive forecast, using the random walk, using the last period forecast. Now, as the name sounds, because it's the last period forecast, okay, if we want to forecast for 7, we just take the 6 to represent the 7. If you want to forecast for 2, you just take for 1. It's as simple as that. So if this is your data set, remember, you have the data set which has only levels and, of course, potential errors, which we will calculate later. So this is basic. Now, how do we get a forecast for 7? As I indicated, this forecast is known as tomorrow's demand will be today's demand. Whatever will happen tomorrow is whatever happened today. That's why it's naive, because you can't guarantee that whatever happens tomorrow is what will happen. It's very easy to use, so a lot of people like to use it, but it doesn't have trend, it doesn't have seasonality. So if trend and seasonality are in your data, this model will not be able to help you. So how do we get to next year? Well, if you look at year 7, since year 6 sales is 28, we'll use that to predict that of year 7. So year 7 will also be 28. It's simple. Okay, now that you've gotten that 28, you use that same idea. So you can see that for year 6, let me use this one. You notice that for year 6, okay, if you look at year 6, we use this year 6 to predict that of the period 6 to predict that of period 7 sales. And that's what you have here. Now that you've gotten the forecast for each value, you can find the errors. How do you find the errors? The errors is basically the forecast minus the actual. Okay, the forecast minus the actual. So how do you find the forecast? How do you find the forecast minus the actual? It's just a minus. So 25 minus 17 will give you 8. And 28 minus 30 will give you -2. So these are the errors. Now, why don't we have a value for the first error? Because we don't have forecast for the first one. Because to forecast, you need a previous value. And since the previous before 17 is nothing, we will not have any forecast for 17 for period 1. Now, there's some important things you need to find before you find all the errors accuracy. After you have detected the errors, you square each of the errors to get the error squared. And then you take each error and divide the error by the actual values. And that will give you the percentage error. Now, this error, together with the square of the error, together with the percentage error, each one will give you a forecast accuracy measure, which we are going to compare. Okay. So, let's calculate the first forecast accuracy. It's known as MAE. Now, for those of you who have been reading, who can tell me the meaning of MAE? I mean, we did that the last time. Who can tell me the meaning of MAE? Yes? Let me pick a couple of names. Yes, someone.
Mean absolute error.
Mean absolute error. If you don't know, this is where you write it, because once you write it down, your pen, your finger is able to transmit information into your brain muscle, and so you are able to keep it. But if you only listen, you realize that if you are asked next time, you're not able to document. Okay. Now, how do you find that? It says that take the error and divide the error by n. Take the error, sum the errors. Okay, that's the summation sum. So all these errors I'm having here, I'm going to sum them. 8 minus 1 is 7, plus 2 plus this is 13, okay, minus 2. Okay, so you're able to use that, and then you get 11. Is it? Let me see. 8 plus 2 is 10. 10 plus 4 is 14. 14 minus 3, yeah, it seems like it's 11. Oh, you have to take the absolute values. Okay, I didn't calculate the absolute value, but you have to take the absolute values. So you take the absolute values of each error. So you can clear all the minuses, and then you keep the absolute values. So when you take the absolute values, you just add all of them. And once you add all of them, you get a value of 9 plus 8. I think it's 19 by 5. The sample size is 5. 1, 2, 3, 4, 5. And that will give you 3.4, mean absolute error. That's the first one. Okay. The second forecast accuracy you're going to use, and at the end of the day, you're going to look for the smallest one, is this same errors but squared. Okay, the original errors, but this time squared. So you square everything from the errors and you get a square of everything. Then you sum them and you divide by the size, the sample size. When you sum all of these and divide by the sample size of 5, you're going to get 17.8. Now, then the root mean squared error. Okay. So this is a mean squared error. The root mean squared error is simply the square root of the mean squared error. That's all. It's like the square root mean squared error. And just take the 17.8, the square root of that, and that will give you 4.22. So far, which error is winning? So far, which forecast accuracy is winning?
I think the mean square error.
The mean squared error. Okay, good. Let's move on. Now, the next thing is to calculate the mapping. The mapping. Who can tell me the full name of the mapping? Who can tell me the full name of the mapping error forecast? Michael.
Moving average percentage error.
Good. Moving average percentage error. We are going to calculate the S mapping. The S mapping. The S stands for what? The S stands for what? Moving average percentage error is the mapping, but the S stands for what? Systematic. Symmetric. Okay. Symmetric moving average percentage error. So take note of this. How do you calculate this? Well, as you can see here, it is just the error at the top divided by this. So this whole thing that you're seeing here, okay, this whole thing that you're seeing here for each one of them, then you multiply by 100, divide by the sample. So this is how you work it. Each one of them. So you see, take each one of them, okay, each one of them, divided by their respective actual values. And you can see the actual values here. The first one is 25, the second is 24, the third is 26. So they becomes the denominator. And once they have become the denominator, you take 100 by this, multiply by that, and then you just expand. And that will give you a MAPE, which is 12.867. 12.867. So who is still winning? And who is losing now? Which forecast accuracy is winning and which one is losing? Who is winning and who is losing? Get a mind? All right. Just pay attention, guys. I'm going to move faster. If you pay attention and you ask me a question, it will help you. Now you calculate the S-MAPE. The S-MAPE is the same thing as the one before. You take the error, divide by the absolute value of the actual and that of the forecast. And then you divide all by 2. Okay. Once you do that, you will now multiply this by the 100 over the n, which is 100 over the sample size. And when you do that, you're going to get an S-MAPE, which is 14.278. Then you can have the last one, which is known as MASE. MASE is a little bit tricky. MASE is actually the MAE divided by the naive MAE. Okay, the naive MAE is used as the benchmark for calculating the MASE. Okay. Who can tell me the full name of the MASE? Who can tell me the full name of the MASE?
Mean absolute scaled error.
Good. Mean absolute scaled error. So you take that the MAE you would have calculated from here, okay, for that particular. Now, in this case, since you are calculating the naive error, so its MAE is its naive error itself. Okay. The naive error's MAE is 3.4. Then the naive MAE is also 3.4. So when you substitute each one of these, this is a naive MAE. If you want to calculate it, 17 by 5. Okay. That is a naive error, and that is 3.4. So you just take the MAE for this method, which happens to be the naive. It's also going to be 3.4, and then you get a MASE of 1. So looking at all of these forecast accuracies, which forecast accuracy on this example would you say that is the best for the naive? In all of these, which is the best for the naive? You can rank them in order of which one is the best. Okay. The next one is the simple average. The simple average is basic. As the name sounds, you just take the average. Okay. The average is a very simple average. So this is a formula. You sum all of the individual actuals, and then you take the average. Now, the advantage of this is that it gives you a smooth random fluctuations, slow to react to changes, and then takes all historical data equally. So there is an equal weight attached to each historical data. Okay. How do you do that? So let's say you want to calculate for period 7. All you got to do is to take the average of every number before it. So if you take, for example, you want to calculate, remember that the first forecast is not known because you are calculating average. Okay, and you don't have an average of numbers before month 1. And so that will be unavailable. However, you have for year period 1. And so you can find the average. The average of 17 is 17 divided by 1, which is 17. That is why the forecast here is 17. The average of 25 and 17, that is 25 plus 17 divided by 2, that will give you 21. And then it can go on and on and on and on. And on the basis of that, you should be able to calculate the forecast for that year. Once again, once you are done, you should be able to calculate the error. It's simple. The error is always the forecast divided by the actual. The forecast divided by the actual. Now, I want someone to calculate the MAE. The MAE, the MAE, I wanted to calculate the forecast accuracy for it. Because all the information that you need to calculate forecast accuracy for the MAE is here. Now, normally you're supposed to develop this table to be able to calculate each one of those forecasts you're talking about. You do some of these things in an exam, so it's important that you are. So who can tell me the value for the MAE? The value for the MAE. What value would you get if you were to do that particular analysis? Let me pick on some few names. Akofa, are you there?
Yes, Doc, I'm here.
Okay, tell me. I'm going to call everybody, so everybody should know. Akofa, you are first. I mean, if you go, I'm going to go alphabetically. So Akofa, tell me.
So, Doc, we are supposed to add and then divide by.
Yeah, do it.
Okay.
Do it and tell me.
Okay.
Everybody do it. Beverly.
Hello, Doc.
What is your answer?
It's 5.
It's 5.
Yes.
What was your numerator?
5.
No, what was your numerator that gave you 5?
Oh, okay. Sorry, I need to.
The denominator is 5. But what was
Yes.
the
So I added the 8 plus 3 plus 4.
added? You tell me the value.
Okay, let me do it again because I left that page. 5, 4.
Doc, I think it's 25 divided by 5.
Sorry?
25 divided by 5.
Yes.
So many of you are talking.
But the error for the man 6 is 3 point something. It's not 3 point.
But you can calculate now.
Yeah. So it's 5.12. That's what I got.
It's 3.4, right?
It will
By
be
showing 3
3.6.
points here, they didn't add anything.
3.6.
It's supposed to be
Okay.
3.6.
Yeah,
Oh.
20 minus 24.4 is 3.6. That's what you're supposed to calculate. That's why I want you to calculate instead of, just look. You see, when an answer is given to you, you are tempted to say, oh, I know. And because it's been given to you, I can do it. But when you are doing it yourself, it changes everything. That's when you realize that you've made a mistake on it. So if you calculate it, what will be your mind? Samuel.
It's 5.12.
Exactly. You're going to get 5.12. Okay. This is what you get for the MAE. Now, the next one is to calculate the next forecast error, and you're going to determine which one is the best. The next forecast error is you take the ones that have been squared, sum them, okay, and then divide it by the sample within that error square, which in this case is 5. So I need an answer from Bishop. Bishop, are you there?
Yes, no.
Good.
So the numerator, I think 135.96. over 5.
That gives you.
Or I think that gives you. I'm punching.
Now,
Sorry.
why do you keep saying I think? These are numbers, and you keep saying I think.
Okay, sorry.
Numbers, you know what they are. Calculator has told you, but you keep saying I think.
Because I'm not sure. I'm punching.
No, you shouldn't be. You are not sure. This is calculator. This is numbers. This is not subjective. So you should be able to. I just want you guys to pay attention. That's all. Some of you are not probably paying attention. Ethel, I need your answer. Ethel.
Please, I'm here. I'm calculating.
Okay.
Just a sec.
And you know, I could
But
easily.
I realized the four, the answer one there is not correct.
All of these answers have been deliberately done so that you calculate.
Okay, please.
I could just give you all the answers, but it's not going to help you until you actually bury your head into it, because you're going to solve these things in an exam situation. So it's imperative that you know what you are calculating. I mean, I can give you all of these formula, but if you don't know how to effectively use them, you will drop. Kwejo, watch it. Kwejo.
Sir, I'm here. I'm working on it.
So I have 30.19.
Working on it.
I have 30.19.
30.19. Okay, that is it. That is the MSE for this particular forecast. That's for the simple average. Now let's go to the next one. If you calculate the RMSE, it's just the square root of the 30.19. And when you do that, you should get 5.49. That leaves us with 3. You now have to calculate the MAPE, okay, as well as the S MAPE. As you know, to do that, you need to have these final column, okay, and substitute and divide each one of them by the Y. And then you multiply that. After summing them, you multiply that by 100 over the N. If you do that correctly, okay, I'm just jumping this because there are some things I want to show you. If you do that correctly, you're going to get that value of 19.215. That was a mapping. Then you can now do the similar one for the S mapping. Again, I told you about how you calculate it. It's the average of the error divided by the forecast. And when you substitute each of these values quickly, you're going to get 21.38. Now, if you check it, it's slightly above the MAPE. The MAPE is 19.215. This one is 21.38. So our last one is the MASE, the MI. Now, this is where it becomes interesting. Remember that when we were calculating, we said the MAE divided by the naive MI. We know the naive MI is 3.4. So you got to calculate the MI here. The MI here we've already calculated. If you remember, the MI here is 5.12 for this simple average forecast. So the MASE is going to be this 5.12 divided by the naive MI, which is 3.1 something. Okay. So you substitute that 3.4. Okay. So you do that value 5.12 by 3.4, and that will give you 1.51. Now, when we get to the Python is going to give us each one of these answers directly. Okay. So you can rank these things from the lowest to the highest. You know, that's the best of the forecast errors to the worst of the forecast errors using this approach. Who is not clear? Okay, let's go to the next one, the moving average. Now, the moving average, last time we looked at it and we said that the moving average it requires you to select a period. So we can say 3-month moving average, 4-month moving average, 6-month moving average, 9-month moving average. To be honest, we don't normally go too far because as you get to 5, it becomes asymptotic. So it is not really a big deal to go a lot. So what does it do? Moving average. In fact, why even the word moving average? So here you are taking the average of the most recent observations, most recent N observations. So you got to define what is your most recent N. Your N can be 3, can be 4, can be 6, can be whatever. Now, this is very good for short-term forecasting. Very short-term, like our data here has. The series has no trend, and here you know we don't have any trend. I'll show you when you have a trend. Then we don't have any seasonality. So this moving average, you can easily do it in Excel. It will smooth the noise better than the simple average, but lags actual changes. Okay. So not seasonality, no trend. We will explain in total what a seasonality or trend is, but for now, that is how you do it. So you have to select the N. How do you do that? Well, some people say that you should do that arbitrarily. Some people say that based on the sample, you should select a sensible one. So you can choose one that is suitable within the nomenclature in which you have been working. So this is our data. My question I want to ask one of you, and of course each one of you, is why do you think that we started from 4, period 4, and not 1, 2, and 3? Okay. Why do you think we started from 4? Okay. The one I have calculated here is for period 7. Okay. So how did I calculate the period 7? I just took the last 3. Now, when you're taking the last 3, it's like 28 plus 30 plus 26. And then you find the average. The average of that is divided by 3, and that will give you 28 for the next period, which is period 7. That's the same thing I did with this 22 and found this 22. And my question is that, why did we start from period 4?
So because it's 3-month moving average.
So
we take the 3 previous months sales and then find the average to get the
so why didn't we get NA for the third period? The third period. Why did we have NA? I mean, given the answer you told me, if it's new, then it is easier. Selena.
We had NA because if we count back, we would only have 2 sales to use for the forecast. We need 3, the immediate 3 before the period that we are looking for.
That is smart. That is how you look at it. That is explanation. So next time when you're in an exam, you're not only calculating numbers, but you know exactly why. So I could have said that you should calculate the 6-month moving average. In that case, which period are we going to calculate? Which period or periods are we going to calculate? If I had said you should calculate a 6-month moving average here.
Oh, only period 7.
Only period 7, exactly. We're going to calculate only for period 7, and every other one will be not available, not available, not available. So that's what I mean by the technicalities of the thing. Okay? You understand the thing so fully that you can now address this very question I asked you. Then I know that you understand. Excellent. So that is it. Once you calculated that, you need to now find the errors, the square of the errors, the absolute value of the errors, and then the errors divided by 3. So as you can see here, the usual things you are supposed to calculate, each one of them. Remember, you must have your forecast. Then you find your error, which is your actual minus the forecast. then the absolute value of the errors, the square of the errors, and then the absolute value of the error divided by the actual output, which is the percentage error. Once you have all of this, you are now ready to calculate your MAE. So what do you think will be the MAE for this? Okay. What would be the mean squared error for this? What would be the mean squared error for this? Mean squared error, very common metric. Let me go to, remember we are just calculating mean squared error. Michael Mohammed, are you here? Michael.
Prof, I'm here, but I think the network breaks, so I couldn't get. Yeah, hello, Prof.
Can you hear me now?
Yes, I can hear you, but the network keeps on breaking, but I couldn't hear the question you asked.
My question is, how do you calculate the MSE? This one, how do you calculate the MSE?
Okay, so pick the absolute
Can you do it? Can you rather do it and let me know your answer?
of the errors.
I think he has a challenge with his network, right? Is it
Okay,
me?
let me try here and then.
He has the challenge with his network. Or you guys cannot
Yes,
hear
no.
me too.
No, I think he has a challenge. It keeps
All right.
breaking.
Who can give me the answer? The mean square root.
14.25 or 14.26. If you want it.
14.25. Okay. But that is not, 14, let me see, yes. 14.26. So this is a mean squared error. Normally we calculate the MI first, isn't it? I don't know why, but this very one, I brought the mean squared error first. But the mean absolute error, the MI, that one should be calculated first. And that one is usual 3.44. The mean squared error is 14.9. You see, because the values are fewer here, okay, you can easily calculate. In an exam, you're going to calculate for all of them, but for one of them, for two of them, you're going to calculate for all. But for the others, you're going to calculate for just the subsequent period. That is, in this case, period 7. Okay, once you find the mean squared error, all you got to do is to take the square root, and then you can find the root mean squared error. That leaves us with a mapping. Because now you know how to calculate, I'm not going to go. The mapping, they come from here. So you just take the values here and divide. It's just a matter of finding the average of the percentage error, basically. The average of the percentage error. The average of the percentage error. Write it down. So in an exam, when you have all of these formulae, you should be able to calculate. And then finally, last but one, the symmetric mapping. The symmetric mapping. So that is going to be the same approach as before because you are dealing with 3 values. It's going to be 39.06 divided by 3, giving you 13.02. So that is a symmetric mapping. Now, the masse. Remember we said the masse is the MAE, the mean absolute error for that particular approach. Which approach are we dealing with? We are dealing with the moving average. Okay, so we go take the moving average here that we are doing, its mean absolute error. That's what we're taking its mean absolute error. And when you come here, its mean absolute error is 3.44. Okay, then we'll take the naive error from the original one. Don't forget that that old naive error is always 3.4. Okay, so you divide the 3.44 by the 3.4, giving you approximately 1. That's how you calculate it. Now you can rank them to determine which one is the best. Which of the forecast method? Which of the forecast accuracies will be the best to do? The one that gives you the smallest error. Now, watch this. If you had used, you see, the moving average, we use 3. Okay. You can also have a different moving average, say 6, and then calculate the errors, all these errors, based on between the 3 and the 6. And then you will select which one is the best among them first. So you can do 3-month moving average, 4-month moving average, 6-month moving average. And then for each one, you calculate their errors. Okay. Then let's say that from all these 3, you've got to know that the one that is best is the 4-month moving average. Then now that you know that is that one you're going to do, you pick that smallest error and come and compare it with these other ones that we have here. Come and compare it. So you would have already selected between the 4-month, the 6-month, and the 3-month. And let's say that you want the 4-month. Then you're coming to now use that 4-month to compare it with a simple average. Then you're going to use that same one, compare it with a naive. So when you pick on this MSE, you're looking for the lowest MSE among all the methods you're going to consider. Then now that you've selected the lowest from each method, now you compare the lowest of the lowest. That is among all of them across all of them. All right. So this is the SMAP 2. Okay, that gives you the 13. And then finally, the naive is the 1.01 that we spoke. The next is to find the weighted moving average. Remember, we've done the moving average already, the weighted moving average. When we go to the Python and to the R, to the Excel, get a better understanding of the graph. What is the weighted moving average? You are using recent observations, more weight than previous observations. So you are so between the year 1999 and the year 2009, which one will be given more weight? Serena, which one will be given more weight? 99 or 2009? 99 or 2009?
I think 2009.
Why?
Why? Because you'd have.
Don't guess. If you guess, you're going to be wrong. Who can help her? Which one are you going to use? Regarding this weighted moving average, which one are you going to deal with? Is it 2009 or 2019 data? Which one are you going to be dealing with? Sophia, I believe. Sophia, are you with us? Sophia, Selena.
No, please, 2019, because it's more recent.
Okay. You were the one I was calling.
Oh, okay. I'm sorry. I didn't get that. Sorry.
No. I'm only trying to find out the one I was calling. If the person is not really connected, then Selena, can you contact the person and let me be sure that the person is here? I need to be sure.
She sent a message in the chat that she's here, but her mic is not working.
Okay. Then she should type her answer here. Now, if she has typed, she should type the answer. Huh? So if I type your answer, instead of you saying that I'm here, why didn't you type the answer rather? You're supposed to type your answer instead of saying I'm here. That way we all know you are here. All right. So, Adams, your answer that you gave was a smart one. Okay. You want to, I mean, the world is moving forward. So if you are going to go back, you go to the recent back than to go to the past back. That's all. Okay. So when you look at the way, guys, you calculate this in an exam, so it's very important you are following. So once you have been given the weight for the first three, and the specific weight you'll be told that the first weight is 60%, the second is 30%, the third is what? The weighting could change. Now, how do you work it? The first weight, and watch the data set very carefully, okay? Because this thing can sometimes be confusing. If you check carefully, the first value, if you suppose you are in period 4, okay, and you are at sales number 26, then if you want to go backward, 24 is the first one, 25 is the second one, and 17 is the next one. So the first weight will be given to the first value. So when you check here, okay, you will notice that the 60% has been given to the most recent value, which was 24. Then the next past, okay, is given that. So if we check carefully, the way the weights have been written, they have been written in a certain order. But I want you to know that in the exam, I will not write it like that. I might misguide you by just writing the smallest first or the middle second, the middle first. But you will have to arrange the weight in the right order. What do I say? You got to arrange the weight in the right order so that you know which weight comes first. It's very, very important, guys. It's very, very important. Because once you use the wrong weight, the ordering, that will smash everything. Francisca J, are you with me? Do you understand what I mean?
Yes, Doc.
What do you understand? What do you understand? What do you understand that you say yes, Doc?
Yes, that you use the weighted with the weighted mean average, you have to use the accurate weight also with the accurate forecast value. If you use for example, if it's the free moving average, you start from the first to the second and then the third.
So what matters here in all of these? What matters here? What
I
really
should
matters?
say the positioning of your weights and then the forecast values.
Good. So the sequence matter. The sequence, the ordering matter a lot when you're doing this. Okay. So if we want to calculate the year 4, as you can see, if I want to calculate the year 4, I'll multiply 26 by 60%, 25 by 30%, and then 17 by 10%. And that is what you did here to get a forecast of 23.6. The same can be done for all of the others. And that will give you all of these forecasts that you see. Now, once again, why are we not focusing on the first 3 period? Because it requires, if you look at the weight alone tells you that you are dealing with the 3 at a go. But there is nothing 3 at a go when you are in period 1, 2, or 3. So that is it. It's the same as the simple average. But the only difference is that the simple average is using the sample size to determine. And then the moving average is using the sample. And then the weighted moving average is using the weight. But there's another way of calculating the weight. Sometimes you calculate the weight by 1 divided by the sample size. Just a minute. Okay. Once you've done this, once again, you calculate all the errors, the square of the errors, the absolute value of the errors, the percentage of the errors. And once you're done with this, you should be able to find your MSE. Who can find the MSC for me here? Who can find the MSC? All of you should calculate. I just want to call one person, but you should all calculate. Who can find the MSC? What is the MSC here? Let me go to find the MSC. Kwajo Boachi, are you here?
So I'm here.
Okay. Do you know how to find the MSC?
Yes, sir.
How do you find it?
So I'm putting the absolute errors together and dividing it by the n, which is 3.
What do you get?
Please, I'm coming. I am punching. So, yeah. 4.7. Oh,
Celine Adams, are you here?
Please, I'm here.
that's it.
I thought you would have finished it.
No, please, I can't find my calculator, so I'm doing it manually.
Yes, Samuel, what did you get?
9.2. Oh, okay, mine is 9.30. Let me be like that. It's 9.296666.
The MAE.
No, MAE. Is the sum of the
Okay, you found the
absolute.
MSC.
Yeah, I did that. I thought you asked for the MS. Sorry.
Okay, yeah, MSC is fine. 9.29.
Yes.
9.297. Good. MSC will give you 2.433. And then the square root of that RMSC will give you 3.049. And then you can find the rest as always. Remember, these are the key errors you're going to be finding. I've given you the best of errors that one can ever deal with in real life situation, and also in thesis. When you're writing your thesis, it's good to, bring some of these. Well, if you bring all of them, it's better because they are easily calculable. And then you can find this S-mapping as well. Okay, we are done with WMA. We are now ready to go to the last one for today before we go to the Excel. Okay. And that is the smooth. You can find the Massey as well, as always. Okay. It is the MAE of this particular method, WMA method, divided by the naive. And in this case, you're going to have 2.433 divided by 3.4. They all divide by 3. You can now rank them from the lowest value, which is the best, to the highest value, which is the worst. Good. Let's look at single or smooth exponential smoothing. In all the ones we have looked at, in everything that we've looked at, there's one thing that stands out. Smooth exponential smoothing uses some kind of simple average or smoothing, a trend fitting, a seasonal adjustment to be able to do the computation. It was propounded by Holt in 1957 in a paper called Forecasting Seasonals and Trends by Exponentially Weighted Averages. Others have extended it. Now, you use this smooth, the simple or the single exponential smoothing if your data set, your time series data set cannot be adequately stationarized. Okay. For example, you are not able to detect stationarity. We'll look at this next week. If it's very, very having some noise, irregularities, or seems to be qualitatively changing the behavior over time, that's when you use this very well. And this is key. If your seasons So it requires you to have seasons. If your seasons are small, if they are not much seasons, I'll give you an example of that data set very soon. Then you should use the SES. Okay. But even though there are seasons, there is no clear season. Or let's put it this way, there's no clear seasonal pattern. Okay. And that is when this becomes useful. So single exponential smoothing is just like the weighted moving average. Okay. But the exponent, okay, the weight attached to them decays, for observations that are very old. How do you calculate it? Well, there is one parameter that controls the smoothing process, which is an alpha. Now remember, the way the data set looks like is that you have a data set. Inside the data set are the levels, and then of course the usual error. It's not different from the rest. How do you calculate this? Well, to be able to get a forecast using this approach, you need one thing. You need something we call the smoothing parameter, which is the alpha here. This smoothing parameter is ranging, first of all, between 0 and 1. And what exactly does it do? It smooths the seasons, the patterns that you might have in the data set. So if the data set is up and down, up and down, up and down, up and down, it smooths that up and downness. The alpha is a smoothing parameter. The 1 minus the alpha is a dampening parameter. When you go to Excel uses the dampening parameter rather. But so Excel will call it alpha, but alpha is actually the dampening parameter. Okay, just to know. So we can say that let 1 minus alpha be beta. And so Excel basically uses beta. Other than that, when you have one, you can find the other because 1 minus 1 is the other. So alpha is the smoothing parameter. If you look at it, once you know the value of the smoothing parameter, you can multiply that by the current or actual value, okay, and then add a marginal effect of the forecast value to it, and then that will give you the next period forecast. Let's take an example. I asked the question here that alpha is closer to 1, and when it is closer to 1, it means that more weight is being given to recent data. I have a question for all of you. These are my questions. So let me go to Francisca J. Are you here? Francisca?
Doc, please. Yes, Doc, please, I'm here.
Okay, so please listen. We are saying that the alpha, which is a smoothing parameter, it is between 0 and 1. And when it is closer to 1, it means that more weight is being given to recent data than past data, okay? Do you understand that part? Francisca, do you understand?
Yes, Doc. Doc, I'm here.
No, I know you are there. I'm only asking whether you understand what I said.
Yes, I do.
Okay, so now my question to you is that, what if the alpha is equal to 1? What does it mean? What does it mean, Francisca, when the alpha is equal to 1? You understand why I was saying that you should pay attention to what I'm saying? And I asked you whether you understand. Because I was going to ask you this question. And so when you didn't understand, you should have told me that, oh, I don't understand. Can you repeat? Are you here, Francisca? Francisca, are you here?
Yes, Doc, I'm here.
So talk to me.
Yes,
What are you
Doc.
thinking about? I need to know your thought process.
Okay, so what I think is saying more if alpha is closer to 1, more weight is given on recent data. Then if alpha is equal to 1, it should means that highest weight would also be given to that data.
Hmm? They are forcing deduction.
Doc, please, maybe my colleagues can help me.
I pick any one of them to help you.
I see Aben's hand is up.
Okay, Eben.
So I am trying. I think that if alpha is equal to 1, it means that the formula is ignoring the other observations and concentrating on the most recent one.
Good. So what does that mean? You're right, but what does that mean? I mean, you've taught mathematically, which is good. So what does that mean in principle?
Yeah.
What does that mean in principle? It simply means this. Let me just solve the mathematics just for you. So if alpha here is 1 and alpha here is 1, it means the whole of this is 0, right? And that means that the forecast that you see here, this forecast is going to be 1 times the YT, which means that the forecast is the current one. So next period forecast is the current period data. And which forecasting technique does that? Which forecasting technique does this? Is it the weighted moving average, or the moving average, or the simple moving average, or the naive forecast? Which one?
Doc, the naive.
The naive. So the moment alpha is exactly 1, we fall back to the naivety. We are back to naive forecast. Because naive forecast puts all the weight on the most recent data, the very last data. That is so if we are focusing for next period, it will put all the weight on the current period. So next period, forecast will be exactly equal to the current period value. Done. That's naive forecast. So that's why we say it's smooth. It doesn't put all your eggs in one basket. This very one, the smooth exponential smoothing, it doesn't put all the eggs in one basket. No, it's spreads it. It's not all 1. It's not all 0. If it is all 0, do you know what that means as well? If it is all 0, it means, okay, that's why the dampening has become worsened. Okay, if it is all 0, it means that the current period is irrelevant. Everything now is on the current forecast. But how do you even get a current forecast if the current period is useless? And so that is why, so you don't put, so the point is that it tries to tell you that, Masa, the way you want to do the forecast, you need data for now, all right. But you also need a forecast for now. What is the forecast for now? And I need you to get me the forecast for now, as well as the actual value for now. You need both. Don't put all your eggs in one basket. And that is what the exponential smoothing is doing. If I ask you to explain this thing in an exam, you should be able to explain. All right. Now, with that, we go back to this thing. We're going to try and then calculate one by one how to do this. So let's estimate a forecast. Now, this very alpha here, this smoothing factor here, remember we said that this method doesn't include this, it doesn't include that. Okay. This can be selected, and it's actually between those two values. So you can select it anytime. Okay, so it's very easy to implement it. Just like the moving average, you can easily implement them in Excel. We'll do that pretty soon. But for now, let's see how we can apply it to our data. We're going to take an alpha value of 0.2, which is a smoothing factor, which means that automatically the 1 minus the alpha, the dampening one, which Excel calls it, is 0.8. We're going to substitute that into the formula for the first one. Let's look at the formula first. This is the formula now. Okay, so if I want to get the next forecast, I need This 0.2 will be the alpha, the 0.8 will be the 1 minus the alpha. I need last today's forecast. I don't have today's forecast. I don't have, but I have today's value. Okay, but I don't have today's forecast. So what do you think the first value is going to be? So it means that the first forecast here is going to be the initial value. The initial value, that is a standard that we tend to use for most studies or most analytics in forecasting. It's going to be the very initial value. Why? Well, we've already said that there's no F. Okay, there's no F here. There's no F value there. Well, if there's no F value there, then the alpha becomes unusable because you need that 1 minus the alpha to be able to get this. So you cannot use this one alone. And so you cannot come and take 0.2 multiplied by the 17. You can't do that. You need both of them. You need both of them. So that's why year 1 becomes that 17. That's the initial forecast. So this very one here, if we come to the forecast, and this one will be 17. However, what about period 2? Well, period 2, as you can see, you need this value. These two values, you need them all the time. You will calculate this in an exam. So take note. So you just need that. Now, what is the current period, the YT? The YT is a 25. Okay. Sorry, we are going to calculate we are doing for F2. So the current period is 17. 17 for the YT. And then the forecast is what you had from F1. So what you had from F1 is 17. So you multiply the 0.8 by the 17. And when you take this, you are going to get 17. So you're going to notice that the F1 and the F2 are going to give you the same value. And then for the F3, you go the same principle. Okay, your alpha is there, your 0.8, which is the 1 minus alpha, is there. Okay, you are going to, this side is always forecast, don't forget, and it's come from here. So this 17 comes from this one there, which replaces this. Now we go to the 25. You take the 25, and then you will get the actual value to be 18.6. And this will continue and continue and continue and continue. In fact, I've even done for the one that we are looking for. And you'll be able to use that principle together. Now here, I've neglected the first one. But other than that, the first one would have naturally been 17 and 17. But because we didn't actually do a forecast for that, sometimes the Excel will say that there's no need to do for the first year or the first period. Why? Because we have already concluded that at that time, there was no forecast. There was no value for the FT cap. There was no forecast for it. And that is why we can leave that. So this is how you do to get the forecast using the exponential smoothing. And once again, once you have this, okay, you can draw this and then showcase how the actual looks like in Excel, which I've done here, and how the forecast looks like here. And you can see clearly why it is called smoothing, because if you look at the actual forecast, it is a bit of rise and fall and a bit of rise and fall, okay? So there's no smoothing there. But if you look at the red one, the smooth exponential forecast, it smoothes the value. And so the value seems to be not being up and down, but a very smooth curve. Okay, so the fluctuations have all been smoothed out. Once you have this, you can now calculate all of the necessary errors as we know of. Every single error, we know how to do this. And then you can calculate the MSE, the MAE, then the root mean squared. Every single one of those that we've been doing, you can calculate. Get your hands on them. Calculate each one of them. You can calculate the Massey, okay, where you now take the MAE for the current smooth exponential divided by the naive MAE. And when you do that, you're going to get 2.0. And now you can rank them. Which of these forecast accuracy is the best for you. If you have a question at any point in time, it is your question that will help me to be able to do this. Now, let's get into the data set that you have. We're going to apply this quickly in Python, and then we'll use our data set that we have to do that of the rest.
Doc, please, I
Yes.
have a question.
Go ahead.
So with all the various forecasting techniques that we've spoken about, please, is it possible to know when to use which, and I mean, at what point?
Exactly. Now, we'll look at that fully next meeting. But I will discuss when to use some of them, when to use each one of them here in the next exercise we are going to do, because here I will draw them. I'll draw some of them so you see it.
Okay, thank you.
Okay. Can you confirm if you see my Jupyter notebook?
Yes, please.
Okay, please, I want all of you to open your Jupyter notebook and follow me. Follow along with me. I have the first command here that you can use to find your working directory if you want to know where all your Python document, your notebooks are being saved. This command will always show you where they are being saved on your computer. Okay. This second one will load the data and show the head if you have the CSV file, which I've given to all of you. So if you have the CSV file, you can load it and then show the head. So this command will load and show the head. That's what I just did. I want to know who has been able to do it. I just need at least one person following along with me. So if you are able to load it, just as I've done, just let me know. If you can't load it, you can use the next command, which I have typed. Okay, you can type it easily, and then you can also load that. So this next command here, in fact, I'm assuming you know all of the key libraries: NumPy, Pandas, Matplotlib, Stats Model. These three, or four, you know all of them already. If you don't know them, you can ask. So this second command, I'm running this. It will also show the data set in a data.
No, sorry, it looks like we are all new to this. So
you are new to this. I was told that you all have learned it.
No,
Yeah.
please, we haven't.
You said that we should download it, so this is the first time.
This is the first time we are.
So this what do you call it?
Using it
Unsupervised learning that they didn't use Python.
No, this is our first time this semester using Python.
Yeah, I mean this semester. So this semester, you've not used it before at all. This is your first time today.
This is the first time.
You scheduled us for today.
Yes, but we downloaded we all have it, but we've not used it.
I know. I mean, you've not used it with me. But
No,
have you anybody?
No.
The rest didn't talk. Have you all not used it with anybody?
No, we haven't.
No, sir.
Oh, wow. Oh, sorry. Then let me give you a bit of tutelage. Okay. But have you opened it at all?
Yes, please. We've opened it.
Okay. So you've opened it means that you know how to at least open a document, right?
We've opened the interface, like the Jupyter notebook. We've opened it.
Okay. Have you opened it, seeing what I'm showing you, or you've opened it, seeing a blank space?
Seeing a blank space.
Okay. Who else has opened a blank space? Which of you sees this data? Guys, talk to me. I need to know before I move faster, before you said I will not done it, we've done that. Talk to me. Communicate.
So I see it. I have a blank space, but I uploaded the CSV also. So I have this interface. However, the month sales is not. I don't have this kind of information. This one, I don't think I have run it. So I don't
you have the codes.
Yes, I have the codes. Yes.
You have the fast check case study written at the top.
Yes, I have it.
Okay. Who else has this fast shifts case study written at the top? Okay, that's fine. Which of you have got an interface that looks like this? Let me just go here and show you something. So if I go to File and click New here and click Notebook, some of you will have this empty slot that is about to open here. Confirm if that's what you have. Do you have something like this? The rest of you,
Yes,
do you have
So
something like this? Let me see by hands those of you who have something like this. Apart from one of you who has that one, who has the fast chips. Let me see those of you who have nothing showing except this one.
I have that.
Okay. Who else? Samuel. So 2 people have it. Only 2 people. Raise your hand if you have it. I need to be sure.
Okay.
Raise your hand if you have it. I need to know the numbers. By first semester, I said they taught you how to do. There's a subject called analytics. What can I say? Programming for analytics. You guys didn't do that.
No, please.
No, please.
No, please.
What is no, please? This girl taught you. Dr. Hanan taught everybody.
No,
So we are in
Doc, this is
operations and
the
supply
OSCM
chain.
class. So.
Not IMS.
Okay. No problem. It's okay. Okay, so have you all opened this very one, this empty slot? Do you have this empty slot? Let me see by hands, those of you have opened this empty slot. Either you've opened the empty slot or you have the other one. Oh, so you're supposed to open these things and you didn't do it and you didn't ask also in the group page. Should have asked in the group page. I want to believe that based on what you guys are saying, some of you have not even downloaded the software. Is that it? Is there anybody here who has not downloaded the software?
No, I've downloaded, but I don't know where to find the digital.
Okay, you've downloaded. What did you download? Did you download Anaconda?
Anaconda Navigator.
Okay. So you go to your stats and then you click on Anaconda. In fact, let me show you something. Let me share my entire screen. Keep your hand up, those of you who have opened the Anaconda at all. Yeah, it's very important to know this. But if not, that's okay. It means that you do more next week with Dr. Ferguson. Keep your hand up if you have opened the Anaconda. Okay. So this is my entire computer. And keep your hand up if you have opened your Anaconda, because I want to be sure that. Okay. Now I have clicked on my start button. The lady who says that she has opened it, but she doesn't know where it is. Do you see my start button I've clicked?
Yeah, Doc.
Do the same thing in yours. When you click on the start button, start typing the word Anaconda. A-N-A. A-N-A-C. When you start typing it, it will pop, like mine has popped up here. And you will see Anaconda Navigator. It is green color. If you have installed, though, if you haven't installed, don't worry yourself. And go and don't search for a ghost. Do you see it?
Yeah, Doc.
Click it to open it. Click to open it. This thing will help you. So I can give you some time to be able to open it. Please, the moment you open it, raise your hand. Okay, so once you open it, you'll be taken to a page similar to what you see on my page here. You'll be taken to a page like this.
Yes, Doc.
Do you see this page?
Yes, please.
Good. Now scroll down, you should see Jupyter Notebook. And this is how you always open. Click on Launch, this Jupyter Notebook. Click on Launch. Once you do that, it's going to take your browser, either your Internet Explorer or Chrome, and it will open. But it will take some bit of time, maybe a minute or two to open. Now, when it opens, it will bring you to a page like this. Now, normally, when it opens, it will bring you to a kind of an empty slotting page. You know, very, very empty page. And you have to click on File on the top left and click on New and click on Notebook. Or sometimes it will open the notebook directly for you, like this. And then you see this pop-up. And in this pop-up, you will see Python 3 kernel, and you click Select. Once you click Select, you will have an empty space. So those of you who have raised your hand, I'm sure you all have your empty space like I'm showing here. Apart from one lady who has a fast chip. Is that correct?
Yes.
Okay, good. So I'm going to assume that you all have not opened the fast chip I gave you. So look at what you have here. Now, this place is called a cell. What you have opened here is called a cell. Ask questions when you don't understand. At the top here, just on the right of Jupyter Notebook, you should have something called Untitled. Do you have that?
Yes, please.
Untitled what? Yours is Untitled number what?
Number 1.
Okay. I hope you're not the only one talking now. I just want to move with all of you before I get there. So Untitled number 1. All right. Click on it. Touch it. It will open like this. And then rename it as Forecasting Module. And when you finish, you click it, rename. You will see that that will be the name for that document. It will save it into your working directory.
I've done that.
Good. Have you all done that?
Yes, Doc.
Good. Now, you still have an empty slot here. Okay. Now, click on the plus and you see more of those empty slots will open. The empty slots are known as code cells. Code cells. So when you click on this plus here, you see more empty cells being open like this. More of the boxes, the cells are opening. You can click and create like 10 of them. 10 of them. That's where you put your commands. 10 of them. You can come back and click on any of those empty cells. Okay. But you can now go and click inside the first one. We're going to be typing inside the first one. Let me know when you are done with that. When you are done with that, say number 1. If you are the next to do it and somebody has said number 1, just say number 2.
Number 1.
Number 2.
Number 3.
Number 4.
I want the 5th person.
Number 5.
All right. So now inside number one, at the first cell, just type 2 plus 5. Just type it as I'm typing. 2 plus 5. 2 plus 5. We are going to use it like a calculator. Just type it 2 plus 5. And once you are done, at the top, below the run, at the top, you should see run, like a play button. You can either click that or control enter. It will give you the answer right below. So click this or do control enter. And once you do control enter, the value will come down as number 7. And that will be 2 plus 5. And you will see the value as number 7. Let me know when you have done that by saying 1 or 2 or 3. If you're the next.
1.
2.
3.
3, 4.
Okay, so you can use the Python as the Jupyter Notebook as a calculator. In fact, you can go and change the plus and just change it, delete it, click and delete it, and do times by pressing the shift and then your star. Okay, and when you now click on the run or you do control enter, you see the number will change to 10. Okay, because it is still treating it like a calculator. Wow, I didn't know that. I didn't know that you guys haven't done it. All right, so now your document I gave you. Do you remember I gave you a document, which I'm sure you have saved it onto your computer somewhere, isn't it?
Yeah,
The
bro.
forecasting document. Where is it saved? Oh, by the way, if you want to know where are your documents being saved, okay, type this. Okay, come to the next cell, and type OS. Just type OS dot get WD, and then do bracket left, bracket right. OS get WD and do bracket, get CWD. Get CWD, like I've just written. And do bracket left and bracket right. Like this. And then run it. Okay. So anytime you get something like I just got, it means that you've made an error. So you might not get this. So go in front of it, enter, and then rather type import OS. Import OS. Type that on top of it before you now run this. When I say run, I mean do control enter or click on the play button. It will tell you where all your documents should be. All your documents should be put, like which folder is containing your document. I've done a whole video on this on my channel. If you just go how to install Python and tutorials, you get all of the Jupyter Notebook. So once you do this import OS, and then you have os.getCWD, then you run it. You click on this play or you do control enter. It will tell you where your working directory is. And you can see that mine is telling me that my working directory is C drive, blah, 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 blah. What is yours?
C uses Bishop.
Sorry?
C uses then /Bishop.
Good. So that is where your working directory is. So that file I sent you, that L3 forecast file, that is where you should go and put into. Go and put it into that L uses Bishop, or C uses Bishop. Drop it there. Drop it there. So all of you, whatever you will see, you drop it there. If you have a challenge, let me know. Because if you do it by yourself without asking questions, you'll be stuck. You'll be delaying yourself.
And Doc,
Go ahead.
I'm seeing /7DF something. I don't know.
That is your computer. That's the name of your computer. You know your name of your computer.
Okay.
That is a folder on your computer. You know your computer has got folders like My Document, pictures, videos, and things.
Yes.
And then you also have your C drive. So when you go to your C drive, you will see this folder. So what command did you see? You saw C colon what?
No, so mine has instead of C column is /home /7D.
Only that.
Let me take a snapshot and
Yes.
just
So your home page, your computer hard drive. Do you have a C drive? You have a C drive, right?
Yes, Doc.
Go to your C drive and double click your C drive.
Okay.
And tell me the folders you see in your C drive. One of them is home. One of the folders you see in your C drive is home.
I don't have home yet.
Have you partitioned your drive?
No, I'm using my work laptop, so if they've not partitioned it.
And you see C drive.
Yes. Local disk C.
And when you double click inside that C drive, what do you see?
So I have iNet, Power, Innovator, Intel, OneDrive, Teams, performance logs, program files, program data, projects, temporary users, and then Windows.
You have temporary users and Windows. You said it's your work file, so maybe they restricted it. Okay. When you go to your computer, do you see this PC?
Yes.
Okay. And when you click on this PC, then you saw the C drive.
Yes.
And after seeing the C drive, before you clicked on the C drive, are there other things you see?
Yeah, it's the
network locations.
Yeah, network locations and then folders at the top.
Network locations and what?
And then folders. So I have some folders at the top. I think it's like I don't know how to describe
All right.
this.
Anyway,
Yeah.
So you double click on the C drive, right?
Yes.
And then the C drive, you can arrange it alphabetically.
Yes.
By clicking on the name. Arrange it alphabetically.
Yes.
Okay. Tell me the first and the last one, the names.
Okay, the first one, it's like there's a $sign, a Windows RE agent, and then the last one is Windows.
Okay. Now, go to H and tell me what you have at H.
H. No, there is no H in here.
There's no letter H.
No.
Okay. I want to believe that they restricted it because it's a computer's work.
Okay. But is there a way I can create like my how do I
Yes,
call it?
if
Yes.
your this thing will allow you. So whilst you are inside, yes, you can. You can, but that would be something outside because I need to just show you and program it for you. That would be outside. But the key point is that
Okay.
directory, that is where you should put your folder there.
Okay. Okay. Let me.
So who else is also having a challenge like that? Okay. So the rest of you, which of you has been able to put that file I sent you into this your directory, into this folder? Which of you? Use your voice.
I have Selena.
Selena, who else?
Bishop.
But Bishop is the one who was complaining that he's not working.
Oh no, it's me, Samuel.
Okay. So Bishop, you've also been able to do.
Yes, please.
Okay, good. So for those of you who have been able to do, follow me here and let's do something. You can teach the rest, or the rest can watch the rest from my video. So when you go to your first chip here, I want you to run this first command. Just run the cell. Put the cursor anywhere in the cell here and click run. It will show you the working directory. Like mine, it just showed me my working directory here. I have created a folder in my Dropbox called Python. So the two of you, Selena and Bishop, can you tell me the name of your folder working directory?
Yes, please. Mine is C forward
Yeah,
slash
forget about
users
this.
forward
Tell
slash
me the last one.
Bishop.
Okay, the last name is Bishop. What about Selena?
It's just user.
Okay, yours is just user. Good. Let's go to the second command. In the second command, the document I sent you is forecast. Okay, and you have the import funders, everything in there. We have named the document inside the Jupyter notebook. We've named it as DF. That's the name we are calling it. It's simply called data file, something like that. So we just call it DF. And then this first one will show you the head of the data set. Run this whole cell, this whole box. Run it. Click anywhere and click the play or do Control Enter and run it and tell me what you will see. Confirm whether you will see the month sales data popping, showing down.
Doc, what you want us to run, is it possible you can put this in the chat box for us to just copy?
Oh, but it's already inside that document. Oh, that document I sent you. I'll still put it there for you. And what I'm saying is that it is something that I sent to you yesterday or so, that you have the document. So
yes, we
if you have dropped that thing into that your Bishop thing, once you run it, it'll pick it.
Oh, okay.
If you have
so the D, so please, sorry. So the DF is where is the location of where the thing is. Is that it?
No, the thing is in your user. That's your folder. But you probably have not put it there. You have not put the forecast document I sent you. You've not dropped it into your user.
Okay, because I'm having an error running it. That's why I wanted to confirm.
Yeah, you will have an error if you have not followed exactly what I've said. You surely have an error. And what I'm saying is that if you don't want to have the error, The document I sent you was known as forecast CSV file, isn't it?
Yes.
It was like an Excel file, wasn't it?
The Excel. Yeah.
That Excel file, copy
Yes,
it
please.
and paste it into that your users folder.
Okay.
That's what I mean. Bishop, that Excel file, copy the file or move the file to your Bishop folder on your computer.
Yes, please.
Before you come and run this command. Okay, in your case, Bishop, in your case, you have not opened this fast chips, have you?
No, please.
You should have told me. You should have told me. That's why you were asking for me to give you the command. Because the fast chip is a Jupyter notebook file I gave you guys as well. If you check your page, it was an IPYNB file.
Yes. So I have to load that one too.
Yeah, put that one.
Okay, I have to open it.
Put it, don't open it. You don't open it like that. That one,
okay.
What you do is that drop it into your Bishop folder that you spoke about. Put everything into that Bishop folder, the Excel, the CSV, all the documents I sent you, put them out there. Yeah, I think one of the things I assumed was that I assumed that you guys have done this. You've been taught this. But on a more serious note, you should watch the video on how to install, how to load, I've done all of this on the channel for you to look at before this. So what I'm going to do is that I'm going to pause here and then I'll rather do with the Excel. I'd rather do with the Excel with you. Do you all have the Excel file? The Excel file wasn't this simple example.
Yes, we have the Excel. The is named the forecasting model.
Mention the proper name.
I want to quickly check it. Yes. It's called forecast.
File about Acme company. This is it. It's like something like this. It's an Excel file like this.
The name is naive, SMA.
Yeah, that's Excel file.
Yeah.
Oh, okay.
That Excel file. I want you all to open your Excel file. Maybe you look at the Python later. Everyone should open that Excel file. It's on your screen here. When you open the Excel file, just give me a number. I want to be sure which of you have opened it. Give your number one.
One.
2.
Open your Excel file and add to the number. You have 3 people so far. Is it 3 people who have opened it?
Four.
Nti even 4 now try and all the kind and can simple. Okay, yeah, so now it's simple. All type in all the kind. It's simple. All right. So for those of you who have opened your Excel, it's very simple. The naive, this is a pure data set. The data set is having years and it has 4 quarters. And then it has the time period. Okay. So the time period ignores whether it's year or quarter. And these are sales. These are sales of a company. The information has been given already in the notebook that I gave you. Also, when you check the slides, okay, when you check the slides, you will notice that the information about this data set is there. It's all been provided. So this is a data set. It's a data for Acme 2 company source. It's a very common example used in business forecasting and planning. So this is a data set. And you have the Excel version you've all opened. If you are told to use naive forecasting to forecast, this is what you do. You come here. Okay, good. And I've done the naive one for all of you. Do you guys see it? I'm going to explain it. Okay, so the first thing is, this is the original data up to here. And here we are going to create a naive forecast. How do you create a naive forecast? And you know that the naive forecast, you have the first data brought here. You leave the first one. Why? Because you are using the past to represent the present. And since if you want to forecast for year 1, there is no past for year 1. There is no year 0 for you to use. So we'll have no forecast for year 1. So year 1 becomes like NA, okay, not available. NA. Oh, what's this? So that is it. Year 1 becomes NA here. And then year 2, okay, it's just a matter of copying everything here and then coming to dump it by starting from this cell. Okay, the cell 3, E3. And that's what you did. And then you paste it. Do you all understand how I got to the naive forecast? Before I go to the errors, do you all understand how I got this one?
Yes, please. Yes, please.
Good. Esther, what's your question? Then you now calculate the errors. How do you calculate the errors? Click here. Okay. You see that the error is the actual, watch it. When you double click, you see. Okay. It is the actual, which is the D3 minus the forecast, which is a E3. So it is a 350 minus the 550. And then you enter. That will give you this. But once you get this, you don't need to do the same thing for all the rest. You move the cursor here. Watch my cursor. Okay. Watch my cursor very carefully. You move the cursor down here, and the cursor will turn black. You see, it was white before. When you move it to the bottom right of the 150, it will turn black. Once it turns black, you double click, and every number will populate automatically for the rest. You just double click when it has turned black, and it will all populate. So that is how you get the error. The next column is to get the absolute value. So we start from here. Okay. So if I were to do the absolute value, all I'll do is I'll click here, type equal to, then type ABS for absolute value. And then I'll double click the ABS, which is the absolute value. And then I will select the 150 because I want to find the absolute value of every error. I click this and click enter. And that's it. And once you get this, imagine I had deleted everything here. Okay. Imagine there was nothing here. Let me just delete. You see, that's why everything else. All I have to do is, now that I know the 150, move the cursor to the bottom right of that cell. Once it turns black, as you can see, double click, and every number is automatically taking that formula. And then you do the same thing for the next one. The next one is a square, the square of the error. So we have the error here. So it's just click here. Let me delete this. You bring equal to. Okay. Once you bring equal to, you take this one. We are squaring it. So to square it, you click square. Well, sometimes you have the square, but you don't have the square. So you just click 150 like this number. Then you do your shift 6 keyboard. Your shift 6 keyboard, and then do that. And that will give you the square of that number. When you enter normal, it will give the square of that number. And then suppose we didn't have anything here. Suppose you didn't have anything here. Now, how do you get these other ones have it? Just click, once the cursor turns black, just double click, and then everything is populated nicely. That's how you get it. And then if you can remember how we were calculating the mapping and all of those ones, they require that you find the error divided by the actual. So if you check here, you take each error here, which is this 150, divided by the sales, okay? And that will give you this. So if you check here, you can see that I'm picking the absolute value, the 150, divided by the sales value, which is a 350. And that gives me this. It's G3 divided by D3. Once you do that, you just click on it and then move the cursor to the right, double click, and all the others below will have their values populated. So that is how you get this aspect. Then the next one is the percentage error. You see, the reason why you got to calculate all this is that once you are done with all this, calculating the MSC and all of those things are easy. So now I have the error here. It says that I should take a percentage of the error. Okay. Now, how do you do it? Just watch. All I do is I take the error, okay, which is this value here, the one that's down here, I3. Okay. And then, actually, it's supposed to be I3 over Y, I3 here. And then you multiply that by 100. That's it. So you can see that each one of these, when you multiply by 100, each one, when you multiply by 100, that's what you get. In fact, this value should be on the right. It's supposed to be not just error, but it's supposed to be errors divided, absolute error divided by this. Okay. I'm just taking the percentage. That's it. And then that will give you all of these numbers. The same thing, when you double click on each one, it will tell you the formula I'm using for the S mapping. That will give you this one as well. Once you've gotten all of these numbers, you can come down here and you can see that using the formula is simple. How do you find the MI? The MI is simply the sum of the absolute errors. If you can remember the formula, you will note. It's a sum of the absolute errors. So when you go to this formula, you will know that that is it. See, the MI is just the sum, okay, of the absolute errors, okay, or the sum of the average of the absolute errors. Okay. And that is what you have here. So you have this, and then you divide, you find the average. The average, I brought it here in the formula. Just check the formula. It's 27. So I take the sum, which is all of these, divided by 27. I type the 27 by my hand, which is the average. And then that's it. Once you enter, you get 151. Using that, you can find the answers to all of these other errors. And boy, oh boy, you will notice that all of them will show. Okay. Now you can draw the curves as well, because here, this was the sales record that I have done. So you should draw your sales. How do you draw the sales? It's very simple. If you want to draw the sales, just highlight this together with the title. highlight this, all this, okay, and just go to insert at the top and click on this line, okay, insert a line or area chart, click on that arrow, and then choose the last but one, okay, this one, okay, that's it. I just chose the last but one, and then I've created the sales here. And then you can now go to the top and select one of these to design it, whichever one you want to use to design. You select any one of them. As you move the cursor on them, you know, I like this one normally. You know which one you can use. If you want the numbers to show, you can also use the numbers to show. I'm deleting this. So you'll get more of these things in the real one, but I want you to take your time and look at this throughout the week. If you have a question along this line, just let me know so that I can explain it further for you on how to execute it. Familiarize yourself with this because you're going to have an assignment that you have to produce a real live data set similar to these ones that I have shown. And then you submit your Excel sheet. It's good. What I want to do now is I want to be sure which one of you has been able to create. I did the naive forecast for all of you, didn't I? I did the naive for all of you, right?
Yes.
Yes, please.
Okay. So now you can see that there's the simple average, I didn't do it. Go to your simple average. You can see that I've left the headings all there for you to do by yourself. Do you realize?
Yes, please.
Good. So what I want you to do, first thing I want you to do is that this sales that I left there, you guys can see, but it's not correct. So I want you to delete the sales. Delete this sales. Click on it and delete it. And then go into this level here. And then we are going to do the simple average forecast together. We are going to do this together. So follow me. Have you all opened it? How many of you have opened it? I want to know how many of you have opened it. If you are part of those who have not opened it, let me know. If you are part of those who have opened yours, let me know by hand. Those of you who have opened your Excel. Catch now for attendance. Catch them. Let them know.
Yes, please.
I'll take it intermittently because nobody sends anything on the page actually. All right, good. So let's start together. Go to your simple average forecast here. We are going to do the simple average forecast. And if you can remember the simple average forecast, just to remind you, because always it's nice to have the formula right with you. This is it. For you to be able to forecast for the next period, you must know the current period. So I want to forecast for period, which is T1. I must know the current period, which is T0. But I don't have the current period, which is T0. So I cannot do for that one. I can't. So this part here, we cannot forecast for this. Because for us to do, we need to know the value, the sales for year 0, times 0, T0. But we don't have T0. So this part here is going to be NA. You just type it there. Guys, I hope you understand that part. If you don't understand us. Now, we are going to go to period 2, which is this one here, period 2. To do period 2 forecast, we need to know period 1 sales. Do we know period 1 sales?
Yes, please.
Yes.
What is it?
500.
500.
So you will now bring your equal to symbol here. Okay. You bring your equal to and then type sum, because remember we are taking the average. Type sum. Do that too. Sum, bracket, and then select the sales 1. Now let me show you something. So you type sum, bracket, then you select this sales, D2. But once you select D2, there must be $1 before the D and $1 after the D. To get that, you should press the FN F4 key. FN down, F4. Sometimes that will not work. So you just press F4. So press FN1, F4. So after you selected the 500, you press F4. And there will be $1 that will come in front and come behind the D. If you press F4 key and it doesn't work, it should rather be FN F4. Who has done that?
I have.
I have as well.
Bishop, you've done that. Okay.
Yes, please.
So you take that sales, then you close a bracket. And then you do divided by the time period. And in this case, the time period is 1. Okay, C1. And that's it. You click enter. So that will give you that. Now, why did we do the FNF4 key? Why did we decide to bring the $1 in front and behind the D? Because we are going to use that same principle to get the others. So that D itself is going to be added to every other one that we are going to do. And you're going to see that. And because we are going to be added, we don't want to be typing it all the time. We just want to do first 2 or 3, and then the rest, we can let Excel populate it automatically for us. Okay. So once you're done with that, you should get 500. Now click here and drag it to the first cell. To the first cell. You should get 250. Shout if you got a 250.
Yes, Doc.
Hi.
If you got a 250, let me know. If you didn't get a 250, we are going to edit it. Like I said, it has to be edited. So when you come here, you come and delete this D2. And then remember, we are looking for the average of the previous sales. So delete this and rather select 350 because you're doing it for the period 3. So you select 350 and then 500. You select 350 and then 500. And that's it. That should give you 425. But let me just check something. That should give you 425. Okay. So,
Doc, please, I have a question. So
I just need to move this one in front.
Okay.
Good. All right. So go back to the first one. So the D2, let's just go back here. Let me just do this one again so that you can follow me here. So when you have, in fact, let me start all again. So once you have the sum, click on the sum, and then select this 350 and then the 500. Okay. But bring the cursor in front of the D2. After the D2, put the cursor there and click on the F and F4 or the F4. So that only the D2, only the D is having a dollar in front and the dollar after. Only the D. After that, close the bracket. Close the bracket and then do your divided by the numbers in front. That is divided by C3, which in this case is the two numbers before it. So you will notice that the first one is C2, okay. The second one is C3, and then after that, you can then double click with this plus. Let me get small. You can then click here. No. You can then copy this very last one here and then drag it to the next one here. And you should get 366. Double click and you see that it is picking the numbers above. Then you go back here, double click. Now it's taking all of them. And then you should have a perfect answer for all of them. You should start from the second one because the first one didn't have anything. If you check the first one, it didn't have a summation. So watch what is happening. If you know the formula, you know the formula. The formula says that you are taking the average of all the previous numbers. Okay, that's a simple average. You're taking the average. So when you double click this, you see that you are taking the average of all the sales divided by 2. When you click this, you're taking the average of all the sales divided by 3. All the 3 sales divided by 3. This next one is taking the average of all the 4 sales divided by 4. This next one is taking all the average of 5 sales divided by 4. You are not going to do it one by one. You just needed the second one, and then you populate the second one by clicking and using that plus symbol to get all of these other numbers populated like that. Just up to here. Who has been able to do this? If you've been able to do this, let me know. If you want to show the formula up there too, let me know. Good. Remember, once you've calculated this, you just calculate the error. How do you do the error? Just bring your equal to symbol, and the error is the actual value minus the forecast. The actual value here is a 350, so you select 350. Then you press your minus the forecast. The forecast value here is 500, so you enter, and that gives you this. Okay. And then once you click on the bottom right, you double click quickly, and it will populate all the answers that you need for the errors. So once again, that gives you the error. In fact, this not available, you can stretch it to all of these so that they will all have the not available. So that gives you the information. You see, the others will start populating once you start getting the answers. Okay. The next thing is to calculate the absolute value of the errors. The absolute value of the errors. How do you do that? Well, it's just typing equal to A, B, S, okay, and just select this number and enter. And that will give you the absolute value. Just click, move the cursor to the bottom right, double click faster, and everything will populate. The absolute values will populate. The next is to find the square. You see, all you need to do normally is to get 1, and the rest will happen automatically. It's a square of the error. So you pick this error, then you do shift 6, number 6, to get to the square symbol. And then you do 2, and you click enter. That will give you the square. Click on it, and the cursor moves to the right, bottom right, double click, and it will populate all the square for you. The next is to take the absolute value and divide it by the actual. So you again bring equal to symbol, take the absolute value, which is this number, divided by the actual value, which in this case is 350 here. Oh no. Take the absolute value, which is 150, bring a division sign by the actual, which is 350. Then you enter. Okay. And that will give you all of this. So you are filling in these information. Okay. You are filling in each one of these information. Okay. The next one is to get the percentage of what you've just done. If I like this one, I said the formula here is supposed to be this very number here, percentage of all of this. So it's not the percentage of just the error, it's the error divided by the actual. So it's a percentage of all of this. So you just come here, take this value, and do times 100. That's all. And that's it. You click on this, you double click to populate all of the rest. And then you finally do the S mapping. The S mapping is a very, very interesting formula. I'm going to show you here. It's an interesting formula. Okay, that you got it right. Let me just put it here for you to see. Watch it. It's a very complex formula, but it just says that if you check the formula, you see, if you check the formula in the slides. Okay, so for example, S mapping, where is that? This one is this whole manya thing here. So if you check it, the top part here is a numerator divided by the absolute value of the actual and the absolute value of the forecast divided by 2. So watch it here. So before you sum it all, but we are not dealing with a sum yet. So you take the gene 3. What is a gene 3? The gene 3 is an error. And that error is the one at the top here. The one at the top here. Yi minus Yi cap. That is it. It's an error in absolute terms. So it's this very number here, gene 3 here, divided by the absolute value of the actual. So D3, the absolute value of this D3, which is 350, plus the absolute value of the forecast, which is in this case 500. And this 500 is a E3. Those two alone divided by 2. So that's what I've put it today. And then all of them multiplied by 100. Divided by 2, all of them multiplied by 100. But it is not the gene 3 which is part of multiply by 100. So look at it carefully here. Okay. So here you have this. Okay. All of them multiply by 100. But if you take the reciprocal of this, it will be like just the numerator alone multiplied by 100, which is exactly the same thing there. So that's what you do, the multiply by 100, and then you enter, and that will give you this value. Once you have this value, the rest is populating the result. You are done. Everything is done. You see, I have the formula down here. So whilst I was doing it, because I was calculating all of this, the formula was happening. So what was the first formula? Look at it. The first formula was this. So mine has already been calculated automatically. All the forecast accuracies have been calculated. How did you get there? It is the sum of, or basically the average of all the absolute errors. That's a MI. In case you've forgotten what a MI is, the MI formula is here. It's at the top here. It's the average of all the absolute errors. So you see the absolute errors divided by n, the sum of the absolute errors divided by n. So you can see that in my own too, I have it here. The sum of the absolute errors, these are the already absolute errors. The sum of that divided by the sample size. The sample size is actually 28 if you check. So why didn't I use 28? I did not use 28 because I omitted the first number. The first number is not available. So you can see that when I was selecting, I selected from the second number to the ending number. And that's it, 140. So the mean absolute error is 140.55. Then the next one is MSE. Now check it from here. The MSE is given by the square. The same thing is the sum of the squared divided by the sample size. And you can see that here I've already calculated the square. So all I need to do is to just sum all this. So I come here, I do a sum of all of them, also divided by 27. That gives me that. It's as simple as possible. In fact, I could have chosen not to do the 27, type it by hand, but I would rather put 127 somewhere. So every time I need it, I pick it. Anytime I need it, I pick it. Okay. So I could have written 27 here, so that anytime I need 27, I do divided by 20, I come and pick the 27, I come and pick the 20. But I was writing it. But it was actually rather nice to have it instead of writing it. So that's it for the second one. Then the RMSE, that's just the square root of this. So you can see that when I double click, you've just written the square root of whatever answer you got here. Straight on. Then you go to MAPE. MAPE, if you check formula for MAPE, okay, that is the whole of this. Watch this. This is the error divided by y, which we have here. Okay, that is an error divided by y. But watch it. It's always nice to go back. Okay, multiply by this. Multiply by 100 over n. So how do you do that? So when you come here, this is it. This is the error divided by this. Okay? And we have already multiplied it by 100, if you can remember. It started with this. So when you check here, you can see that we've already done the multiplication by 100. Now, all I need to do is to divide, sum this, sum all of these, and then divide it by 27, which is what I did here. Okay? Take the average of all these. Oh, where am I? Okay, we've done the multiplication, so you just take the average. Okay, you just take the average because they've already been, summed from here. You take the average divided by, by taking the average, you've already done it. Okay, you see, you rather take the sum divided by 27, or you don't even take the sum, you rather take the average, which means it's a sum divided by the sample size. And that's what I've just done directly. In fact, all of these could have been done directly like that. For example, if you take this one here, I took the sum divided by 27. Instead of taking the sum divided by 27, we could have written average like this, average of everything here. That's it. Watch it. Average of everything. Done. And you see, you get the same thing. You get the same answer. So instead of taking the sum divided by that, you can take just the average. And you don't do any divided by. And that is exactly what this one is doing. And then the last one, the SMAPE. The SMAPE has been calculated here. So once again, all you do is take the average, which is like take the sum divided by the sample size. You take the average. That's it. What about the MASE? The MASE, if you can remember, it is the actual naive year, the MI, divided by the naive mine. Okay, the naive mine, it is already obtained somewhere in the previous sheet. Okay? This naive mine is not here, it is rather here. It's down here. The naive mine is this. So this naive mine, okay, 151, I take this value, which was a Gene 31, the 140 divided by the 151. That's what gave us the 0.92. So that is exactly how you got to execute these Excel situation. I've just gone through the simple average. Use the same principle to do the moving average. Okay, so this is a 3-month moving average. Oh, and by the way, this one you can do it in Excel straight on. Okay, but of course, the errors, you have to calculate it. So, but I've given you the same formula analysis. Go through it and solve it, because you're going to get something similar like this as an assignment and also as a project to be able to do it for your own. And then you can use the same thing for the weighted moving average. Okay, that one is also done here. That one I've done it for you. Each one I draw. What do I draw? You draw the sales as well as the forecast. So you draw the sales and the naive forecast. That was the first one. Sales and naive forecast. That's here. Second one, you draw the sales and then the simple average forecast. Draw that. Oh, actually, we didn't draw that, but you can draw that easily. So now that we have the value, you can just click these two, drag it, sales and then simple average forecast. Drag these two down up to the end, and then go to the insert. Click on this arrow here, insert line, and choose that last but one. Okay, that's it. So you have the sales, which is the blue one, and then you have the simple average forecast. And you can see that the simple average forecast is running in between the center as the average moving on. And so it helps you to see what is being captured right here. So one of you asked a question. I don't know whether the guy is still here. He says that when do you use which one? Who asked that question? Okay. Is there any one of you who remembers the one who asked the question, when do you use which one?
Bishop.
But the person who asked that question is not here.
Oh, I'm here. Sorry, I was responding. I didn't know I was on mute. Sorry.
The person is not here.
Oh, please, can you hear me? I'm here. Okay. I was on mute when I was talking.
For the benefit of the rest of you, you use the one based on 3 things or 4 things. One, you first have to check whether they are levels. All of them have got levels. Okay, you have the actual level. But you check whether they are trend or seasonality. There's a way you take it. Use the STL, seasonal trend, lowest decomposition. And we'll look at that in our subsequent meeting. But you check that, you estimate that. And once you estimate that and it has it, then you use that. If it doesn't, you don't. For most of the ones that we are doing today, you don't know, well, they all don't have that sort of trend or season. They don't. However, one way you will know which one you're going to use is to use the errors. You use the errors. First of all, you got to do all. It's not a matter of, you got to do all. And then you check which one mimics the reality. You check the errors. For example, the little I've done here, if you check the naive, my error is what? Is big, 151. And then the simple average error is 140, so it's smaller. Okay. Now let's look at even the Massey forecast for the simple average. The simple average Massey is 0.92. And then the naive is 1. So you can see that the naive is suffering. The naive is suffering. The simple average is doing well in all the forecast accuracies. How do I know? Look at the MAPE and the S-MAPE. The naive is having 36 and 36. The simple average is having 34 and 33. So you can see that the simple average is doing well in terms of errors than the naive in all angles. Okay, let's look at the MSE. Okay. The MSE is 29,074, and then this one. This one is 140. No. I don't think that's the one we're doing. This one is 32,000. So in terms of the MSC, you can see that the naive, the simple average is losing. But in all the rest, you can see that the simple average is winning in all angles. So on the basis of that, naive will struggle with this. So we are going to now take the simple average and compare its results now with the moving average. That's how you do it. And then wonder whichever is the winner on average, you compare the winner with the weighted moving average. And whoever is a winner, you compare the winner with a simple exponential smoothing. And that is how you go around checking all of this. Fantastic. Ladies and gentlemen, that brings us to the end of the entire caboodle. Okay. Now, what I'm going to do is I wanted to go and do this. Familiarize yourself with it. If you have a challenge, let me know, but I'll go through it again so that you'll be able to understand it. Or I'll do a new video about it so that you can watch it and understand. Other than that, it's been a pleasure having you. I wish you all the very best. Have a wonderful